Joe, welcome to Sir Joe Math class. I'm reminding you, if you haven't subscribe to the page, like the page, leave a comment, and share with your friends. Today we are going to look at indices, and by the end of today's tutorial, you are going to understand the laws of what indices and master them. If you have them on your fingertips or you can memorize them, you can solve any indices question that will be given to you. Now let's look at the first law. The first law says that if the bases are the same and they are multiplying, factor one base out and what? Add the exponent. So let's say am times an. You factor one base out, then you add the exponent. So this is going to give you am plus n. Let's look at the example. Let's say we have 3 exponent 4 times 3 exponent 2. It is going to give you 3 exponent 4 plus 2, which is giving you 3 exponent 6. Now let's look at example 2. Let's say we have 5 exponent 2y times 5 exponent x. This is going to give us, we will factor one base out, 5. Then you add the exponent, so it is going to be 2y plus x. Now let's look at law 2. We have am divides an. Yet we have the base to be the same. So you factor one out, you write 1, and then you subtract the exponent. So it is going to give you am minus n. So this is what we are going to get. Let's look at the example and see something. We have, let's say, 3 exponent 4 divides 3 exponent 2, which is going to give you 3 exponent 4 minus 2, which is giving you 3 exponent 2. Let's look at the last example. You have 5 exponent 2y divides 5 exponent x. This is going to give you 5 exponent 2y minus x. Now let's look at something. Now let's look at this one too. Let's say we have a exponent m multiplying n here. This one we have only one base, but the exponents are 2. That is m, and another exponent or another power of what? N. This is, in this case, n is going to multiply n. So we are going to get am n. This is what you are going to get. So let's look at the example. Let's say we have 2 exponent 3, and then we have 4 here. This is going to be 2 exponent 3 times 4, which is going to give us 2 exponent 12. 2 exponent 12. Or let's say we have 3 exponent 2x, and we have 3 here. This is going to give us 3 exponent 2 us 36x. 36x. Let's look at log 4. If you have something like, let me drop it down small. If you have something like a over b, or exponent n, this one become quite different than those that you've done. This one is the same as an over bn. So n will multiply, will become the exponent of a, and also exponent of what? B. Let's look at this example. Let's say we have something like 3 over 4 or exponent 2y. Then it is going to give you 3 2y over 4 2y. This is what you are going to get. Now let's look at another one. Now let's look at this one too. Let's say we have a exponent m over n. Wow. The base is 1, but then the exponents are dividing. This means that we can express n as a fraction of m. That is, we have a 1 over n times what? M. We can express it like this, which is the same as root of n a n. This is what you are going to get. It tells you that this is what? A root of a. So you write it in this form. Now let's take an example and see. Let's say we have 3 over 5 over 2 here. We have 3 5 over 2 here, which is 3 half of what? 5, and it can be written as root of 3 exponent 5. This is what you are going to get. Or let's say we have 3 2x over, say, y. Yes, let me write y. It is going to be like 3 exponent 1 over y times 2x, which is going to give us root of y and 3 2x. Someone may say, hey, do you have root of y? I intentionally write it this way because you may get a number, or let's say y is representing a number. Now let's look at 6. Let's say a exponent 0. We know that a exponent 0, or any number exponent 0 is 1, right? If any number exponent 0 is 1, then we can say that a exponent 0 or a exponent 1 over a exponent 1 is equal to 1. Or we can say a exponent 2 or a exponent 2 is what? 1. You can write it this way. Just because the bases are the same, the exponents are the same, and they are what? They are divided. It is going to be what? 1. Let's prove something. You let me leave this one here. Let's further this one. Let's further this one. A exponent 0 is equal to a exponent 2 all over a exponent 2. This one alone, as we did earlier, the exponents are the same and they are divided, so we can write a exponent 2 minus exponent 2, which is giving us a exponent 0. You see, we've come back to this place and it's the same as what? 1. And it's the same as what? 1. So let's say example 5 exponent 0. Let's say is the same as 5 exponent 2 over, let me write 3. 5 exponent 3. It is going to give us 1. Because the bases are the same, the exponents are also the same. So they are going to give us 1. Now let's look at the last law. Now let's look at the last one. I think it's 7. Let's say you have a exponent n. A exponent n, which means you can reciprocate this one, or you can write the reciprocate of this one. So it's a, this is equal to 1 over a n. This is how it is going to be. If it is going to be like this, then we can say that a exponent 0 is the same as a exponent n, which is going to give us 1 over a n. Because we know that any number raised to the power 0 is what? 1. So you repeat your a exponent n here. So a exponent negative n is the same as a exponent 0 divides a exponent what? N. As we did for the number 6, this one too can be, I'm expressing a exponent 0 over a exponent n alone. You will get a, the bases are the same, you factor 1 out. They are dividing, so you will what? Subtract the exponent, so you are going to get 0 minus n, which is giving you a minus n. You see that it comes back to this place, and we are saying that this one is the same as this. So if a exponent negative n is going to give us 1 over a exponent, then we can write this expression. Let's take example and see. Let's see example. We have 3 exponent 2. It is equal to 1 over 3 squared. And expressing this one alone, we can say 3 minus 2 is equal to 3 exponent 0 over 3 over 2, which is going to give us 1 over 3. Thank you for your time. Thanks for watching. I'm reminding you, if you haven't subscribed to the page, subscribe to the page, like the page, leave a comment and share with your friends. And then if you are a teacher, say mathematics teacher, and you find this page useful, you can recommend it to your students so that they will follow and they are going to get more worked examples to better their understanding. So if you are a teacher and you find this page useful, you can recommend it to your students. Don't forget to subscribe, don't forget to like the page, don't forget to leave a comment, and then don't forget to share with your friends. Thank you.